All right, gang, Math 6610. More on repeated measures, ANOVA. I just want to pump the brakes a little bit and just uh, circle back and make sure that we're all on the same page here. Now, because I think it's easy to not fully understand what we're doing with the repeated measures, ANOVA. Now, first of all, this data set we've seen before. We have 6 students in this class who have a pre-score, mid-score, and a post-score. I think of this as they took a pretest, then they took a midterm, and then they took a final exam. And we want to see, as tested by the against the null hypothesis, if the mean for pre is equal to the mean for the mid is equal to the mean for the post. Okay. Now, it's so tempting to just run a straightforward ANOVA of score over measurement, and when you do, we get a p-value of 0.254, indicating that we do not have statistical significance. Now, what's the issue with that? Why don't we just use that straightforward approach? The assumptions for using ANOVA are, and again, we should have these tattooed to the brain now because we've used them so much: independence, equal variances, and normality. For the sake of this discussion, I don't even care about the normality right now. I don't even care about the equal variance. We've already tested it for this data set. We've seen that the assumptions are met. But let's talk about the independence assumption, which, by the way, is the most important statistical decision, a statistical assumption that we need. You can't violate independence any more than having a measurement, repeated measurements on the same person. So by running this design, we are getting a result which is completely meaningless because we know we violated the independence assumption. In fact, in testing this null hypothesis, are the means equal across pre, mid, and post? Right now, I don't know what the p-value is, but I can guarantee you it's not 0.254. So what we have to do is we have to control for, adjust the variance for the repeated measures design, that we have multiple subjects who are measured at multiple time points, okay? And what we've seen so far is we can use the easy ANOVA command. I'm not going to go through all of this because I did it in a previous, reviewed that in a previous video. But what I would like for you to see is, let's go back up and grab this command that we've used many times before. And it turns out if we make an adjustment to that, and we make the adjustment by examining the error term and partitioning the variance for subject over measurement. No, don't do that. In fact, if you want to get it wrong, do that. We have to set this as a factor first. Now, what you're going to get when we do this is a very interesting, output, and it gives us quite a bit of information. Now, look what happened, and this is something that I tried to point out, I think, in the very first video. What we are allowed to do, well, not allowed to do, but what we end up doing is we end up kind of partitioning out the error sum squares. So the 715, notice how it is reduced to 57.22 when we take in, or I should say, when we account for the subject variation. So again, that's what we're seeking to do. We're seeking to reduce this the residual sum squares by I don't want to say controlling for, just adjusting for the sum of squares across the subject, repeated subjects, or not repeated subjects, but different subjects. All right, so I hope that helped a little bit. The cool thing about the Easy ANOVA, I really like this output. I like the simplicity of it, and I like that it reminds us of something we've used quite a bit before. But the great thing about this output is it gives us our test of sphericity information, and it gives us our generalized eta squared for our effect size. All right, speaking of, let's talk a little bit about effect size. Now, this effect size, remember the threshold is what, 0.01, 0.06, 0.14. So 0.16 would be a high effect size. But we can use that to our advantage, in a sense, to calculate our priori power. Now, we're living in the ANOVA family, so there should be no debate on what family that we use. And we want to get into a repeated measures between factor. Now, here's the issue starting out. We have an effect size, but notice it's the F effect size, Cohen's F. And we're actually given the generalized eta squared. Well, it turns out that we can convert F by taking the square root of 0.167 divided by 1 minus 0.167. So the formula is for converting the the generalized eta square, which again in our case is 0.167, to convert the generalized eta square to the Cohen's F, take the square root divided by 1 minus. All right, so we end up getting a Cohen's F of 0.491, let's call it. So let's grab G power. Error probability, this is all straightforward. Number of groups, we have 3 measurements, and number of measurements in each group is 6 students. Now, here's something I really don't like about G power. Well, there's a lot of things I don't like about G power, from being completely transparent. But one thing I don't like about G power when it calculates the priori effect size for repeated measures is this correlation among repeated measures. I've spent a lot of time, far too much time. I've gone down too many deep rabbit holes, and ended up wasting a lot of time on how to make this calculation. I really don't want to go there in this video. A lot of people, there's a lot of debate. Some people say, well, you need to use a Fisher correction transformation method, because what I need here is I need the correlation among pre and post, pre and mid, and mid and post. Some people state that let's just use what we call a poor man's approach to this and get the average of the correlations. Well, in R, that's kind of difficult to do. So I have found, if you come up with a way to do that, then good for you. But I have found probably the easiest way to calculate these pairwise correlation, well, these correlations, is just go back to our Excel spreadsheet. And I can use the correlation function, and I can just drag that and drag that, and get the first correlation. All right, so then I want to compare pre with post. And then I want to I don't know why it doesn't grab that. Mid and post. Now, if you think this approach is a little suspicious, now let's just find the average of those. Or if you can come up with a much simpler way to do this in R, good for you. So I got 0.911, which I'm going to put right there. Now, I'm not even going to go into, I'm partially ashamed to demonstrate this method to you. Obviously, I'm not so ashamed that I didn't do it. I don't know what else to do. And again, it's not like I've just spent a couple of minutes exploring this. I would say that I've spent hours and hours and hours trying to figure out what G power actually wants here. And the consensus is a lot of people don't know, including me. So I think just to get an estimate of for a priori power, I think this approach is okay. All right, anyway, enough said. So calculate, we need a total sample size of about 42. We have 18, which says we have fall short on adequate power. And if you know a way to create the correlations quickly in R this way, then go for it. So yeah, there we go. That's about all I have to say about effect size. And it sounds like Forrest Gump, don't it? That's all I have to say about that. It's a little wacky, but again, I'm not sure what else we can do. Now, let's switch gears a little bit. We're going to return to repeated measures ANOVA in future videos, but right now, I want to focus on how to import an SPSS file into R. Now, you can identify an SPSS file, and I have one right here, tutormarks.sav. So when we see the extension .sav, we can immediately think that we have a file that's in SPSS format. And getting a file like this, in fact, it turns out there's a lot of really cool files in SPSS format. The problem is I used to use SPSS. I was a big SAS SPSS fan, and but they both got so expensive that we had to switch gears. But still, there's sometimes some nice data sets in SPSS. So here's how we get those installed. Now, first thing we need to do is install the package. I've already installed it, so all I need to do is access a library. It's called the foreign package. And the next thing I will do is grab my data. And instead of using read.csv, we'll use the read.spss command. And I can drag my file from the desktop or whatever, wherever. And the trick is to get that between the quotation. The next thing I need is I need to set the use value label command equal to true. And most importantly, I need to convert to a data frame. All right, so let's attach our data and take a look at our data, and we can see that we have our data set imported into R. But this is not the way we want our data set, right? Because we want to have our scores in one variable and then our tutors in another variable. We have two variables here, our scores and which tutor actually graded the test. Let me explain to you what's going on here. What they're doing, they have 4 tutors let's think of Student Success Center, and they want to see if one tutor is maybe more lenient or one tutor grades more harshly. So they have one person submit some work, and then they have it graded by tutor 1, tutor 2, tutor 3, tutor 4. So they have 8 subjects, and the purpose here is to see if one tutor is a more lenient or harsher grader. So let's next thing we'd want to do is stack our data. And of course, always attach the new data. And we can see now that we have our data in working format almost. Still have an issue, don't we? And the issue is in all of the repeated measures commands, we have to have a subject variable. And we don't have a subject variable. Now, you may say, well, you have the subject variable over here. Well, that's not going to work because we don't have 32 subjects. We need this to be 1 through 8. Then we need starting right here to be 1 through 8. And we need this to be 1 through 8. And, of course, tutor 4, 1 through 8. The easiest way I know to do that is just to create a new variable called ID. Well, I'll tell you what, we've been consistent with calling that subject. And what I would do here is I would repeat ones 8 times. Then I would repeat 2 8 times. You'll never guess what comes next. And repeat 4 8 times. Now we need to kind of mash this all together. So I'm going to go, I'm just going to call it data 999. This just happens to be a name of a data set that I use after I do a lot of manipulations. So I want a new data frame. And I want subject, values, and independent. Attach it so we can do stuff with it. And now we can see data 999 is is ready to be analyzed. All right. Okay. Well, we're going to use this data set in an upcoming video, but I just wanted to prepare you for, because we're going to have a whole lot going on in this next video. And I knew I was going to have very little going on in this video, so I wanted to kind of keep the videos around 20 minutes. All right, if I'd quit talking, we would, right? All right, take care.